As I will tell you in class, I'm going to be departing from the book's technique of talking about inverse functions. This is section 5.1 in the college algebra text. I want to do it my way, and this is one of those cases where if I had the teachers or the textbook writers, I would let them know that, in my opinion, they lost ground here. And that's because I want to teach you why we do things in math. I don't want to teach you a formula. I don't want to teach you a cookbook thing where you, oh, I need to go do this thing right here and follow these rules. Never has there been such a better example of that sort of egregious type of math teaching than in this chapter, section 5.1. Let's do it my way. At least give me the time of day. Here we go. I'm starting with two definitions. The first one has to do with a one-to-one function. And basically, I'm saying that if I've got that a function is one-to-one if it will pass this horizontal line test. A parabola, like our favorite f of x equals x squared, is not one-to-one because there are two places here, here's an A, here's a B, where f of A and f of B are the same value. This is not a one-to-one function. Whereas it's pretty easy to draw some, just any function here. There's no place along this where a horizontal line crosses in more than just one place. It's always in one place. This is going to be a one-to-one function. That's important because when we start talking about inverses, I cannot talk about the inverse of a function where I have two y values, or I'm sorry, the same y value for two different x values. I have to have this what's the word I want? I have to have this thing of one-to-oneness on my function for that to work. Here is my definition of an inverse function. If a function is one-to-one on a domain D and has range P, now I picked P only because if I do R and do the double letters, you're going to think I'm talking about real numbers or the set of real numbers, and I'm not. I'm just talking about some range. Then there exists a unique function f inverse of x that has domain P and range D, so the domains and ranges swap, and I can compose these functions and get x. F inverse of f of x is x, and f of f inverse of x is x. Here's an example. Let's suppose f of x is 2x plus 5. I want to find f inverse of x. Well, I know from this property here that if I do f of f inverse of x, that's going to equal x. But f of x tells me to put this in, this is my slot. That's the whole reason I talked about slots at the beginning of our foray into functions, because I wanted to be able to do this. Here's my slot. F says take that, whatever's in this slot, multiply it times 2 and add 5. Well, here I have the function f inverse of x in my slot. So I'm going to take f of f inverse of x simply says to take 2 times f inverse of x and add 5 to it. But on the other side of the equation is this. From my definition, this is going to equal x. All I have to do now is do the algebraic manipulation to get f inverse all by itself. First thing I'm going to do is subtract 5 from both sides. So I get x minus 5 is equal to 2 times the f inverse of x. Now I'm going to divide both sides by 2. And so I get x minus 5 divided by 2 is equal to f inverse of x. This is my function. This is my inverse. If I take any x, let's say I take x equal to 7. And I put 7 in here. 7 minus 5 is 2. 2 divided by 2 is 1. If I take 1 and put it in here for x, 2 times 1 is 2, plus 5 is 7. I get back to my original x value. That's how inverses work. You start from one side, you get a certain value. The inverse throws it back.